This is the third part of the CES production function question. The question is, show that Q, which is output, is equal to gamma times delta L raised power negative a plus 1 minus delta times k raised power negative a whole raised power negative 1 upon a is a production function that represents the average of two inputs, labor and capital, for different values of a, which is this a, given our gamma is greater than 0 and delta lies between 0 and 1. So in fact, this is our constant elasticity substitution production function. So I have written it here. This shows us, as I explained it in part first, this shows us the efficiency parameter. The growth in the output that is not explained, or the share of the output that is not being explained by the inputs, labor and capital. Okay, growth contributed by the total factor productivity or state of technology. Okay, so delta denotes the distribution parameter. This delta is distribution parameter. It shows us the relative share of labor and capital in the total output, and this a is our substitution parameter. Now in the part 1 we discuss it. Since this is a CS production function, we need to show that for different values of a, this represents different kind of production function. So in the first case we have seen, as a approaches to negative 1, this production function approached to, or it became linear production function, and which showed weighted arithmetic mean of labor and capital. In the first part I have explained it. In the second part, which was a bit long, so as a approaches to 0, this production function, this CS production function, approached to Cobb-Douglas production function, which showed us the rather geometric mean of labor and capital. Now we need to take the last case, when a approaches to infinity. What happens to this constant elasticity substitution production function? Itna bada now. So let's take. So first thing is first, let us assume, or let us say, in this case, if L is less than k, okay, if L is less than k, that implies L raised power minus a will be greater than k raised power minus a. Okay, why? So if I write it like this, it will be 1 divided by L raised power a. Here we will get 1 divided by k raised power a. Since L is less than k, this is smaller compared to this. So the smaller the numerator, the greater the number. Since this is smaller than this, so this number will be greater. Okay, so this was to explain to you. Now we have this production function. Okay, so what will we do here? So Q is equal to, we have gamma. Let's take this L raised power minus a common. So L raised power minus a, if I take common, we will be left with so we will be left with this delta, then we have plus 1 minus delta, and here we will get k raised power minus a upon L raised power minus a. Why? Because if I multiply with this and this will get cancelled here. Okay, and let me rewrite it here to save the space. I will get k upon L whole raised power a. Then we have this Shinai Magaz minus 1 upon a. Okay, we assume if units of labor are less than units of if units of L are less than units of K, so we will get this result. So as this a approaches to infinity, what will happen in this production function? Let us see. Here it is negative a. Okay, so what will happen to k upon l? If a approaches to infinity, k upon l raised power minus a, it will approach to 0. Why? So can I write k upon l like this? K 1 divided by k upon l raised power positive a. Limit is a approaches to infinity. That means if a becomes positively greater and greater and greater, so you will have 1 divided by a very large number. Okay, so 1 divided by a very large number, so it will approach to 0. It will approach to 0. Simple thing, no tension here. Okay, so what will we get here? As a approaches to infinity, so our production function will approach to gamma l raised power minus a. So I'm just getting rid of this only for the sake of simplicity. Then we will get so we have l raised power minus a. Since this is 0, so 0 times this, this will become 0, so we'll have delta only whole raised power negative 1 upon a. Again see, as a approaches to infinity, in this case, so we'll get here, if I rewrite it here, so we'll gamma l raised power, we have minus a divided by minus a. So if I multiply it with this times del raised power negative 1 upon a. Okay, if so this gets cancelled, we are left with gamma times l times del raised power negative 1 upon a. So if a approaches to infinity here, so what will happen to this del? So let me write it here. Limit as a approaches to infinity of del negative 1 upon a. So it will become, we have del, if I plug a, if a approaches to infinity here, what will happen? We will get a negative times 1 divided by a very large number. So 1 divided by a very large number, it will become 0. So negative 0, it will 1 divided by a very large number, because a approaches to infinity. So you will get del raised power negative 0, which is equal to 0. Anything raised power 0 is in fact equal to 1. So what we got here is a approaches to infinity, q is equal to gamma l, because this is equal to 1. Now if we take another case, if k is, or l, why I am taking this, if l is greater than k, let us take it again, then that means so l, we will have l raised power minus a, it will be less than k raised power minus a, as I explained it here. So in this case, then if we take this whole process, what will we get? Similarly, we will get q is equal to gamma k. Okay, as a approaches to infinity. That means as a approaches to infinity, the production function approaches to Leontief production function, that is q is equal to gamma times minimum of L K. Okay, so these were the 3 cases. I hope I have so I was not within the limits. I hope I make myself clear in this video. Thank you.